Right, we have different types of reactions in grade 10, right? Remember, you have precipitation type reactions. You're going to learn about acid-base reactions, gas forming reactions, and the likes, right? So now this one in particular, since they say calcium carbonate reacts completely with 30 centimeter cubed of hydrochloric acid of that concentration, we must know how to write calcium carbonate. Now in term 1, you must have learned how to name compounds. That is the first chapter in chemistry, so that we understand how to name these ones. So calcium is Ca, and remember it's 2 plus, and then carbonate, remember it's CO3 2 minus. So it means calcium carbonate is simply CaCO3. Now it reacts completely with hydrochloric acid. Let's remember that HCl is the hydrochloric acid. And now what is formed there, right? What is formed is that these ones, they are going to we are going to form a salt and water there, ne?
Okay.
We're going to form a salt and water. So that salt, how it forms, right, is that in HCl the H is donated, right, meaning it moves and then it goes to Ca, like this. You're going to have H2 CO3 plus CaCl2. Oh, wait, I'm lying. This is a metal carbonate and an acid. So we should form a salt, water plus carbon dioxide. So we have to form H2O. We have to form carbon dioxide. And then let's see, if we have carbon dioxide there, means we have oxygen left. So it means, yeah, CaCl2. Is it balanced? 3, 1.
So
Mm-hmm.
I have a
Mm-hmm.
so why you see after the atoms after the ion, why did you say H2O, or like where does H2O come
It's the type of the reaction. It's a metal carbonate plus an acid. So when you have a metal carbonate plus an acid, we form H2O, carbon dioxide. So meaning we form water, carbon dioxide, and then a salt. So what do you have here? Let me write it. It's water, carbon dioxide, and then a salt, right? So where does it come from, like you asked, right? So from here, if we remove, all right, from here on CO3, ne, what will happen is that the CO3 is going to split into two things. It's going to split into CO2 and then oxygen, okay?
from? Yes, sir.
Because it's CO3. Oh, sorry. So it means it will be oxygen there. Yeah. And then the hydrogen will come and join. It's going to come and join there. So because it would want to join the oxygens, there must be two of them, right? So that it can be able to bond with the hydrogen, and then they form what? They form H2O there. Sorry. No, sorry. We'll need two of them, again, so that they can bond
Yes,
with
sir.
oxygen, they form H2O. Obviously, because it happens at atomic level, there's always, it's not just HCl, only one of it. Like, it's not just two atoms, H and Cl. Remember, there are so many of them. I get.
Yes,
So
sir.
the H, they can actually, two hydrogens, they can actually come and then combine with the oxygen from CO3, and then they form H2O, as you can see there. Then this would be what? Would be the carbon dioxide. And get.
Oh,
Then
oh. So, sir,
the
so
the
is it compulsory that if they give us like an equation that's similar to this, should we find H2O? Is it compulsory for us to find H2O, or also do it without H2O? If they give us an equation to balance that's similar to this one.
Yes, I know it is very much compulsory to find H2O. In fact, you always have H2O for these type of reactions, acid base, and then when you also have a carbonate, you will have H2O there. Okay, in most cases,
So if you have an acid and a carbonate, there are high chances that you're gonna have H2O when you have to balance.
all the time, all the time.
Oh, oh,
Yes, yes.
okay,
Any acid and a carbonate, you're gonna have H2O. You're gonna have carbon dioxide.
okay.
Then the remaining ones here, they join to form calcium chloride, as you can see there. Ne?
Yes, sir.
Yes, so that's where everything is coming from there. But I think we'll touch more on that when we have to talk about the different type of reactions. Right. It's my hope that they won't expect you to actually draw out the equation. Usually they actually give you the equation. Wabona?
And then you just have to like balance the left hand side and the right hand side.
Yes, yes. For example, this one you see there's two hydrogens and then here it's only one. So you have to put a two there to balance and get.
Oh, yes, yes.
Then it will be balanced because even chlorines there are two, and then even here we are saying that there will be two, and then oxygens there are three, and then you can see oxygens are three. You have a carbon, you have a carbon, and then you have a calcium, and then you have a calcium. So yeah, the equation is balanced.
Okay, yes, sir.
That was
I see.
for 8.1. Now for 8.2, now when you have the equation now, it's much easier to answer the questions. They say calculate the number of moles of acid that has reacted. Let's remember that the acid is this one, and get, and then
Yes.
this one would be the base. The carbonate would be the base.
Okay.
So we have 30 centimeter cubed of hydrochloric acid of this acid. We have 30 centimeter cubed. Let's remember what is 30 centimeter cubed. It means we are given the volume, right?
Yes, sir.
And let's remember, how do we convert centimeter cubed to decimeter cubed? Because we don't work in centimeter cubed.
We divide by 1,000 to get this meter cube.
Yes, so we're gonna divide that by 1,000. So it means that now we can calculate the number of moles of acid that had reacted. For the acid, we're given the volume, and then we're given also, what is this that we're given here?
The number of moles. Oh no, I'm lying. Oh yes, yeah. It's the number of moles. It's the number of moles.
This one is actually the concentration. Okay,
Concentration. So what would be the unit for moles?
it's mole. It's just mole.
Oh, okay, okay, okay. I see, sir. I see.
Yes, yes. We should always remember that. I usually say that if we can remember that N is mole, right? Um,
Mm-hmm.
M is mass, which is measured in grams, and then capital letter M is molar mass. I get,
Yes, yes.
which is measured in grams per mole,
Mole. Oh, okay,
and then V is volume. I get, measured in decimeter cubed,
okay.
and then we also have VM, which is called molar volume. Okay, molar volume. Now, molar volume, remember mass and molar mass. Mass was grams, molar mass was the grams per mole. Here we have volume as decimeter cubed. Molar volume will still be decimeter cubed, but we put per mole.
Oh, so is molar volume the one where you like where you combine the formula for like C is equals to N over V and C is equals to M over V, but then the M and the V are the denominators. Is it something like that for molar volume?
Oh, for molar volume is actually this one. Molar volume is N is equals to V over Vm.
Oh,
Yes, remember that this is the molar volume there, and remember that it's given as 22,45, I think, decimeter cubed.
so it's this one that's used for is it gas or liquids?
Gases at STP. Ne? It's used for gases at STP.
Wow. Okay. Cool.
Alright, and then concentration is then um, um, mole, right? Mole per decimeter cubed. So it kind of like just switches. Or what?
Okay.
So I can say the units you need to remember mostly it is these four: grams per mole, decimeter cubed, mole per decimeter cubed. Okay. Right. Then for 8.2, since they gave us the concentration and the number of moles, we can use that to calculate the number of moles of the acid that reacted. So now we can say C is equal to N over V. Anger.
Yes, sir.
The concentration is 0.5. Nice. And then the volume we're given to be 35 by 1000, I think is 0.03 if I'm not mistaken.
So I'll check. Let me see. I think um wait. 20 divided by 1,000. Yes, sir, it's 0.03
Great. Then
for
then we cross multiply okay, so that we get number of moles. So how much will it be?
it will be 0.5 times 0.03, which is 0.015.
But remember to round off to two decimal digits again, because it's the final answer.
Because my calculator gives me 0.015. I'm using a casual.
Yeah, but remember we need um yes we need two decimal digits on top after the comma.
All right. Okay.
Yes, because it's the final answer. Okay.
Yes.
Right, so that will be 8.2 there, and then for 8.3, calculate the mass of the calcium carbonate that has reacted. Now, remember the calcium carbonate is this one, right?
Yes, sir.
I want you to check the question. Do you have any information given about calcium carbonate?
Because they say that calcium carbonate reacts. No, I don't think we have a thing that calcium carbonate, a question that's given for it. Because they tell us that it reacts with um hydro, hydrochloric acid.
Yes, my man. If we can check for hydrochloric acid, we are given numbers such as 30, we are given numbers such as 0.5 and the units, which tells us that they are giving us some information about the hydrochloric acid, such as the volume and the concentration. Anger.
Yes, sir.
So my question is, do you have any information about either number of moles, volume, or concentration of calcium carbonate?
No, sir.
We don't have, right?
Yes.
So that is where stoichiometry comes into play, because we are given information about the acid, we don't know nothing about the base, but we can use what we have to get what we do not have. You understand me? Or what we want.
Yes, sir.
So now that's when the ratio that says what you have is to what you want comes into play. What you have is the number of moles of the acid. That's why I usually prefer that you write it actually to say these are the number of moles of HCl, okay?
Yes, sir.
So that you are aware of what you are talking about. So since these are number of moles of HCl, that is what we have. We're going to use them to get what we want, which is the number of moles of what? Of calcium carbonate. Because remember, to get the mass of calcium carbonate, you first start by getting the number of moles. Angel.
Okay. Yes, sir.
So we say you want the number of moles of calcium carbonate. Next thing, you're going to check the coefficients. The coefficient here is 1. On HCl, the coefficient is 2. Do you see it?
Yes, yes, sir. I see. I see.
Right, for acid we're going to put 2, and then for the base, the carbonate, we put 1 to say that the number next to the acid, the coefficient is 2, the base is 1, as you can see there. Now, from what we have, we substitute what we have. Remember that we are given this one, so we're gonna substitute it there to say we are given 0,02, but we do not have the number of moles of this one. We don't have, it's the one we want, so we're just going to write it as it is, like this.
Okay.
Then after that, you are going to cross multiply.
Yes, sir.
Now when you cross multiply, you will have 2n of calcium carbonate is equal to 0,02. Then you divide by 2 both sides, so that you just get the number of moles of the calcium carbonate. How many are they there?
Um, let me see. So gonna be 0,01.
Great.
Yes. 0.
Great. So now we have, that is stoichiometry there. Now we have the number of moles of the calcium carbonate that we didn't have before, right?
Yes, sir.
But the question wanted us to get the mass of that calcium carbonate. So since we have number of moles, if we can still remember the diagram, we said if you have number of moles, you can get anything else. And get.
Yes, sir.
So now we're going to get the mass. We then say therefore, since the number of moles is equals to mass over molar mass, we shall substitute the number of moles there to say 0,01. We do not have the mass of the calcium carbonate. I like to be specific, that's why I put them in brackets. And then the molar mass of calcium carbonate, you will then add, I think it will be 40 plus 12 plus 16 times 3. Is it 40 for calcium?
Calcium.
Mm.
So let me grab my calculator.
Mm-hmm.
Yes, calcium is 40,
Mm-hmm.
and calcium is 40, carbon is 4,
Mm-hmm.
oxygen is 16 multiplied by 3 because of the substitute.
Right. So 16 multiplied by 3 is 48, and then plus 12, you get 60, and then you get 100, isn't it?
Yes, we get 100 grams per mole.
Perfect. So here we'll put 100 here.
Okay.
Then to get the mass, remember it's just cross multiplication. You say M into CaCO3 will be equal to this times that, which means it's going to be 1 gram.
Okay. Yes.
Is the one, eh?
Yes. It's 1 gram. 1 gram.
Perfect. So that is how you use stoichiometry. Use what you have or calculated to get what you want. Wabona?
Yes, sir.
Right. And then lastly, they said calculate the volume of the gas that will be formed at STP, isn't it?
Yes, sir.
Now, the products are in yellow. You see where you see yellow there? These are the products here. These are what are formed. The reactants are this side, which are forming the products. Again.
Yes, sir.
Now, when they said the volume of gas that will be formed, the only gas that was formed there is actually carbon dioxide. Do you see that?
Yes, sir. Yes.
Right. So we're going to calculate the volume of that gas. But do you have any information about carbon dioxide? The number of moles or volume or anything?
No, we don't have any information.
Great. Then we use stoichiometry. You understand me?
Yes, sir.
So for 8.4, we shall then say what we have is to what we want. Still, we have the number of moles of hydrochloric acid. So that is the one we're going to use to say we have. Now, we want the number of moles of that gas, which is carbon dioxide. And yet,
Okay. Yes, sir.
what is the ratio between them?
For the HCl,
Mm-hmm.
coefficient is 1. And then
Check
it's not
HCl.
2. No, it's 2, sir.
2, right?
The inside it's 1.
Carbon dioxide
It's
is 1.
1.
Aha. Then this one, remember, we already have. Angel, that is the one we have. We substitute it there, 0.02, and in this one we do not have. Then now our goal is to then simplify. We then say, cross multiplication, 0.02 times 1 is 0.02. 2 times that is 2 NCO2. Then you're going to divide by 2 both sides. Therefore, the number of the carbon dioxide moles is 0.01 mole. Ne?
Yes, sir. Yes.
Perfect. Now that you have the number of moles, you go to the question. The question said volume. So you then say, the volume, and they even mentioned STP, isn't it?
Yes, sir.
Then definitely you know we are using this volume here, right?
Okay, I see.
Great. So we then say, therefore, number of moles will be equal to V over Vm. Now, the number of moles we calculated to be 0.01. The volume of the gas we do not know, so I'm just going to write the volume of the carbon dioxide gas.
For the volume part, don't we use the one we found from the beginning, which was 0.03?
Volume we found at the beginning, 0.03. Oh, remember, that one was for HCl. You used to remember?
Okay.
Yes, it's for hydrochloric acid. You must always track or is the volume for which substance, ne?
Yes, sir.
Yeah, so for this one we do not have. But we know that the molar volume, since they mentioned STP, the molar volume will be this one. I get it.
Yes, sir.
Then we cross multiply the volume of that carbon dioxide gas would be equal to this times that 0.01 multiplied by 22.45. What do you get?
So I get 0.224.
0.224. Now remember 2 decimal digits.
So do we round up to the whole number? Because my calculator gives me 0.224.
Yes, if it gave you 0,224, remember we need two digits after the comma. So you look at the third
Oh,
one. If it's below
oh,
5,
okay.
you discard it. But if it is above 5, you still discard it but add 1 there.
Oh, should in other words, the answer is 0.22 there.
Yes, Amelia. Yes, yes. So that is
Oh,
how we
okay.
get, that's how we would get the volume there. And the units must be accurate. Angel.
Yes, yes.
Alright, so I
Okay.
hope that gave you the required revision on stoichiometry.
Yes. Yes, so you've answered all my problems. I just want to practice later on.
Okay, that's good. That's good. Now, in terms of vectors and scalars, those are quite a huge chapter. And get they require a lot of a bit of time so that we
Mm.
discuss. But usually, how I navigate through this topic, right, is to say I would teach you. Remember, Gary, you have vectors and scalars. You have list of vectors. What are vectors? What are scalars? Um, these are measurements. You are measuring something in a way because we are talking about physical quantities. You are measuring. You can measure time, you can measure mass, you can measure temperature and stuff. So you are measuring. But there are some things that when you measure them, you don't need to talk about their direction. For example, you don't need to stand on a balance. You don't need to say when you are standing on a balance there, your mass is showing 20 kg, right? You say your mass is 20 kg to the left. You don't need to include balance. So that means that your mass is a scalar quantity because we don't need to include, direction, not balance. You don't need to include direction, right? You can just simply say your mass is 20 kg. I cannot say, Dando, what time is it? You tell me, right now it's 24 minutes to 8 to the left. You understand me? It wouldn't make sense. Or right now it's 20 past 7 to the right. It doesn't make sense. You understand me? So those things
Yes.
we don't need to include. Yes, we don't need to include direction. So those ones are called the scalars. So time is one of the things you don't need to include direction. Mass is also one of the things you don't include direction. Temperature, you cannot say today it's very hot. It's so 20 degrees Celsius to the right. It doesn't make sense. Or you say,
Okay.
yes, or you say the volume of this box is 5 meters, is 5 cubic centimeters or downwards. It doesn't make sense. You need just to give it um, its volume and no direction. Even distance, if you are moving from here, you travel there, you go like this, and then maybe you come back again, right? And then you come here. And then I ask you, what was your distance that you traveled? You cannot tell me that the distance was maybe, let's just say, it's 100. You can't tell me up, down, left, or right because you tend a lot. So because distance has to do with addition of the total path length, we just say it's a scalar, right? So
Okay. Yes.
yes, so these are your scalar quantities that you must know by heart.